Welcome back to the channel. In a recent video we were disassembling an Amstrad PC1512 to see if we could get it working, and this is the motherboard from that system. And if you've watched the video, you'll know that we found there was a problem with the floppy disk controller area somewhere up here, and I was debating whether to try and fix this by replacing parts or whether to just get a replacement motherboard. And I got my eye on a couple of different motherboards, as I mentioned in the video, and in the end I pulled the trigger on one of them because, oh well, I'll show you why in a second, but it's kind of cheating, I know, but I felt that it was probably worth it in this particular case. So let's have a look at the box and see what's in it, and we'll see why I made that decision. So this is the box in question. Looks like a fairly big shoebox kind of dimensions. So having removed that plastic wrapper, I feel a bit charged static wise, so I'm just going to ground myself on something. So now that I'm a little bit less likely to kill this motherboard taking it out of the box, let's get it out. So it looks like it's been fairly well wrapped, although there is a lot of room in here. This could have moved around quite a lot in transit. Hopefully it hasn't. And it is in an anti-static bag, which is very, very welcome. So let's take it out and have a look at it. So, looks very similar to the other motherboard, but there are some important differences. The most important is hiding under this floppy drive cable. So let's move the power to one side. So this one has already got the empty slots populated. So this has had its RAM upgraded from 512 kilobytes to 640 kilobytes. And that's what attracted me to this, mainly because these chips are quite hard to find, and they're also quite hard to find, you know, starting to show their age, they're starting to stop working. So if this is fully populated and is said to be working, then presumably all these chips are working, which is really, really nice. So hopefully this is just going to be a straight slot-in replacement, but we're going to get that advantage of the extra memory, which is really, really good. Let's just compare the two boards side by side first. So both boards are kind of very, very similar, and as you would expect, but there are some subtle differences between them, which I think might be important. One is this one's got a load of bodge wires up here by the video circuitry output, and the original board doesn't have that. The original board does have a bodge wire here, which this one doesn't have. So that's very interesting. Otherwise the boards look very, very similar. They're both early revision boards with the large number of RAM sockets, in this case populated, in this case empty. But otherwise I think the boards are pretty similar. They both have a model number on. So the new board is an MC0032B, whereas the original board is an MC0032D. So it's obviously a D revision versus a B revision. So this is a little bit earlier. We've got a computer with a serial number, and we've got a matching box with a serial number. So the fact we're putting in an extra motherboard that's a little bit earlier is a little bit disappointing, but that's the way it goes. We could still try and fix this motherboard and swap the RAM over, which we might do at a later date, but in terms of expediency, we're just going to put this new board into the machine. Everything looks exactly the same as far as I can tell visually. One of the differences is that the the CGA ROM or character maps are in a socketed chip on this motherboard and not on this one, so there may be a difference in the character sets. Everything else looks the same. All the other components are soldered to the board apart from the two Amstrad ROMs. They have the same part numbers, but they are made by different companies by the looks of it. This has got extra writing on it. And the other thing that's socketed obviously is the CPU, and next to that is an MT8087 socket. Now I do actually have an 8087, so as this has been upgraded in terms of RAM, we could definitely consider putting the 8087 in here to make it a kind of fully upgraded system. Anyway, let's put this in the machine, see if it works. I call these bodge wires, but they're actually not. On the later revision board, there's a resistor pack in that position, and here what you've got is a load of wires with an inline resistor in the middle of the wire, which is very interesting, but not technically a bodge wire, I would say. If we look underneath, the resistor pack has actually been soldered to the bottom of the board, which is interesting. There's no other components on the bottom, and obviously that's not there on the original board. So reassembling is going to be the reverse process of what we did originally. I'm going to do it on a slightly different camera angle just so you can see some slight differences from this angle. First of all, let's just place the motherboard in place. So you need to get these holes lined up on the left of the board and the ones at the back simultaneously. There we go. Let's get the volume knob back on before we forget. So there's a flat side on the receiver, and then there's the flat side on the knob, and the flat side is also where the slit is. So that should just slide on. There we go. You can do that before or after you put the screws in, makes no difference. But it just means we won't forget it later on. Before the main RF shield goes in, we need to put in this small RF shield that covers the ISO slots, and that basically fits down between the space between the motherboard and the chassis. And there's a little grounding plate on the motherboard that it connects to. Then on goes the main RF shield, and it's pretty straightforward. It kind of self-aligns, but you do need to pass these cables up through the holes first. And it's a little bit sharp on the edges, so just be careful with the cables, particularly this floppy drive cable, because the individual wires are quite thin and exposed. So that's the floppy drive cable through, and we've got the power cables come up through this D-shaped hole. So that just drops into place. You may have to move this one capacitor that sticks up through the RF shield. You may have to just kind of move that to make sure it fits. But otherwise, things are looking like they're in the right place. Talking of being in the right place, this motherboard doesn't have a hole for this screw here at the front, which is interesting. Obviously there was a hole on the other one. So what you need to do is now get the RF shield, the motherboard, and the posts underneath all in line, so you can start putting screws in. Let's pick an easy one. I'm just picking one in this corner, and I'm just putting it in loosely so that we can swivel around that to align the others. So I'm going to put one in diagonally opposite. Again, I've only put it in 3/4 tight. Make sure the other holes look like they're going to line up. And the other thing we need to do is put this L-shaped bracket around the CGA connector, and a single screw goes through both that and the RF shield. So you need to put it in now. Let's get the rest of the screws in. So the RF shield's a little bit springy, so you may have to just put a little bit of pressure on it to make the screws line up. And because you're screwing into plastic posts, if there's any resistance, you need to turn the screw the other way until it clicks. Obviously we're going to have a screw left over here. So there is indeed a hole in the motherboard here, but not on this prior generation motherboard. Because this was sold to me as a working motherboard, I'm actually just going to go ahead and fully assemble this, at least 90%, rather than testing it at this stage, which is what I would probably prefer to do. So we're just going to carry on putting on these connectors. So the short one here is for the speaker, PC speaker, and the longer one is for the LED power light on the front. Interesting, that's not going on easily. It could be one of those pins is slightly bent. There you go. Let's keep those out of the way. So now the motherboard and the RF shield are in place, we can start reassembling the drives. So we have two floppy drives. B was the one with the retainer on the back, so that goes on the right hand side. A goes on the left hand side. And A has to go over B. So you have to put B in first and then A afterwards. if you put them in the wrong way around, they don't line up on the front. So make sure you get that right. So I've not got any screws in yet, but let's plug it in at this point and see if we do have a working motherboard or whether I've been sold a dud. Let's reconnect the power and the data first. So the caddies have these cutouts on the back for you to put the power and data cables through. Short one's obviously going to go on this side. The long one goes over here. And conversely with the data cables, this one goes on this one. And this one goes on this one. So unlike on 3.5-inch drives, on these particular drives, I don't know if it's the same with all 5.25-inch drives, the red cable is away from the power, not next to the power. So that's a little bit different from kind of more modern PCs. Okay, so we've got reassembled, 2 drives not screwed in but connected, monitors back. Let's turn it on to see if we've got a working board. Power light has come on. It is eerily that these don't make a noise when you turn them on. Got a please wait on the screen. So the following step is where it failed. Faulty floppy disk controller or disk drive. Okay, that was unexpected. So what that means potentially is that we have 2 faulty motherboards, which seems unlikely, or we have 2 faulty floppy disk drives, which also seems unlikely, because we tried each of these drives individually with the previous motherboard, and we tried a new motherboard with these drives. So that doesn't make sense. So as far as fault diagnosis goes, there's 2 other things to consider. One is that the other components that are attached to this motherboard are causing a problem. It seems very unlikely, but the monitor is the power supply. So if there's a problem with the power supply, could that be upsetting the motherboard? And this keyboard. Is there a short in the keyboard maybe that's causing a problem? So what we should do is try a different monitor, try a different keyboard, and see if that makes a difference as well. Seems unlikely, but they're the other possibilities that are the commonality between the 2 systems now. Before we change the keyboard on the monitor, just going back to a comment that was made in the first video, is that people have reported this error when the NVR battery isn't connected. So let's just reconnect that. As I said, it has not been my experience that has helped, but it's worth a try given the weirdness we're experiencing so far. Nope, still getting the same error, so it's not the batteries. Trying another keyboard is easy, I have a surplus of those. Nope, same error. Okay, here's another 1512 monitor. I can prove that to you because it's on the other side. So this is a known good monitor. This is one that I use on my normal 1512. Let's give it a go. Faulty floppy disk controller or disk drive. Okay, so at this point in time, it's looking like both those floppy disks are faulty. So that's interesting. Okay, perhaps we should try that experiment again with the floppy drives actually plugged in. Nope, still the same error. So here is the known good floppy drive from my normal 1512. We're going to try this and see if this makes any difference. So we are getting the same error still. So if my maths is correct, that just means we happen to have 2 faulty motherboards that failed in exactly the same way, even though one was sold to me as working. I don't think I've missed any steps. We'll try a couple more things. Okay, some success. So I'd forgotten that these Amstrad drives have a jumper on them that lets them detect whether they're drive A or B. They don't detect that from the cable, you have to set it manually. So this was drive B in my other machine. I've now put it in as drive A in this machine, and it has now booted. It looks like we've got 2 faulty floppy drives, which is pretty unheard of in my experience. I've not come across a 1512 or a 1640 yet that's actually had both floppy drives fail. Well, there's a first time for everything. So what we should be able to do is put the other motherboard back in, and then at least it will be age appropriate. This is a version 1 motherboard. You can see it's detected the 640k of RAM, so the RAM upgrade is working, which is great. So I could always transfer that over to another board, but it looks like we need to source 2 more floppy drives, not another motherboard. So that's interesting. Anyway, some progress. So it seems we have 2 faulty floppy disk drives. So that could be an electrical fault, that's probably the most likely, but just to rule out a mechanical fault, let's take them apart, do a quick bit of servicing, and just see if anything obvious like the spindle is frozen stiff, or if the head's not moving or something, because that will probably also return an error as far as the drive controller is concerned. So let's take them apart and check them physically. So this is drive A, let's do that one first, because we can then at least test the system with one drive in. And basically what you've got is this big metallic caddy, and it's the drive itself held in position with 4 screws, 2 on each side. They come out, the drive's kind of like in the middle of the caddy, it's like there's a gap at the top and the bottom. I'm not really sure what Amstrad were thinking, maybe they had suppliers that had very slightly different sizes floppy disk drives and they just wanted to make some allowance for that, but you know, these are things that are pretty standard. They have defined heights by convention, so not sure why they've done that. Anyway, let's take it out and have a look. The other thing is the back here, so there's 2 sets of cutouts for drives. There's the one that's being used currently, so they got the data and power here, but lower down there's another one, so no idea, just no idea what they were thinking. So I'm just going to support the drive by the front when we take out this last screw, because it will drop otherwise. And there it goes. So here we have the drive itself. It's an Amstrad branded one. It's a different layout to the one that I've just taken apart and changed the jumper on. So it's obviously made by a different manufacturer for them. It's got some Sony chips on, so it might be a Sony drive. Let's see if there's any other identifying marks on it. So nothing on this side. Yeah, there's a mark on the back here, so we can work out who the manufacturer is. Around the side, nothing on this side particularly. There's another sticker here on the stepper motor. No particular branding on that. Looking at the surface, there's a set of resistors and some small capacitors. Nothing that's electrolytic that I can see straight away. Oh, there's a couple down here, but they look in good condition. The main mechanism seems to be working in terms of gripping the disc, the floppy disk. That seems all right. It looks pretty clean as well. It doesn't look like there's been years and years of dust in here, which is nothing that may cause it to fail. On the bottom, we've got this direct drive motor. It's running freely, as you can see, so that's not a problem. So it could be that the head isn't moving freely. You can't see the head currently because it's hidden underneath this piece of metal, and it's not clear whether that is easy to remove. It looks like there's one screw at this end which is easy, but then it looks like it goes underneath the motherboard. So I'm not sure how easy it is going to be to remove that, which is what we need access to be able to see if the head is moving properly. Let's give it a go. So yeah, unfortunately it is not going to be a case of just removing that one screw. It looks like we need to remove some of these others as well. The cables are a little bit in the way. I'm hoping we can get it off with just these 2. They are smaller than the other screws, so we need to keep them separate. Is this now loose enough to get at? No. Washer's just fallen out, which is rather worrying. So obviously there was a washer underneath one of those. It has become a little bit loose. So I think this metal component also contains these little cable clips. So let's see if we can loosen those without pressing on the motherboard. Looks like I've loosened this one a little bit. This one doesn't have any traces underneath it, so that's going to be a little bit easier to loosen. This one here is still a little bit tight. And directly underneath it are those traces, so I need to put something between the screwdriver so close. Yeah, I think it is just those two things. Now we've lifted them up a little bit. Let's see if I can get pliers underneath. Well, it's definitely that which is holding it in place. But now we have a new problem. Okay, managed to get it off. That wasn't the best bit of filming, sorry. But this is what we've been after accessing. This is the drive head controlled by this motor. So it should move backwards and forwards when voltage is applied to this motor. It runs on this rail here on the top, which is what opens and closes it when this is moved. And then there's two silver rails down at the bottom that it slides on to go forwards and backwards. So let's just try and give all that a bit of a clean and then power it back on and see if that helps. So unfortunately I didn't catch that on camera, but basically what I did was I put my screwdriver into one of the screws that is on the stepper motor, and then I just moved it backwards and forward, and it was really stiff initially. It is now moving extremely freely, so I think that may have been the problem. I'm still going to have a quick look at the rails and if there's anything else that's obvious wrong with this, but I think that may have been it, that it was unable to move the heads. So that might be an easy fix. So I've just quickly reassembled everything. We've got one drive in, the A drive, hopefully, yes. And this is the one that I freed up the mechanism in. So let's just power it on and see what happens now. Getting the please wait. Ta-da! Okay, so it looks like there were two faulty drives, but not electronically. It looks like it's going to be a mechanical issue. It looks like the drive is just stuck in place from having been stored for 30 years and not turned on. So let's service the other one. I'll try and make a video that's a little bit clearer about what I did. Okay, so this motor is running freely. That's not a problem. That was happening on the other drive. It's this motor here that was stuck. So just in here, there's a little screw, and we're going to use that to our advantage. We're going to use that to free up this motor by sticking a screwdriver in it and just giving it a slight tug. So we're not going to disassemble the mechanism. We're just going to try and get a screwdriver in there and see if we can do it without taking it apart. And there you go. So I don't know if you heard that, but there was a bit of a clunk when it first started moving, and it's now moving freely. Let's try that. So I've freed up both drives, and we got a boot with one drive in. Let's see if we can get a boot with both drives in. Just thinking about it. It's making all the right noises. So yeah, so it has not gone to an error message. It's asking for a floppy drive. So these are the floppy disks that came with the system. They're not the original Amstrad ones, but they are copies of the original Amstrad ones. Let's see if they work. It's making the right noises. Slight squeak as the drive moves. Maybe it does need lubricating. but it's worked. We have a booted system. So this is version 3.2 of MS-DOS that's supplied with Amstrad PC1512s. In fact, let's leave that in there for a second. Let's have a look if the B drive is now working. And it is perfect. Okay, so we now have two working drives. Let's put it back together. But we've got the dilemma of what to do about this motherboard. So this is a version 1 motherboard. I think the one we took out probably, I'm guessing, is going to be a version 1.3 in the BIOS. So do we put it back in, or do we keep this one because it's got the extra memory, or do we switch the memory over to the other machine? So many decisions. I'll have a little think about that. If you have a strong feeling, put a comment down below and we'll see if we agree or not. But let me just get this all back together, then we'll hook it up. We'll put the PicoMem in, so we've got a bootable hard disk and we can have a play around with some software and we can see if we get that printer working. Right, so we're all reassembled. Let's just go for the 2-disk drive experience before we put a hard drive in there. So let's turn it on. What I'm going to do is I'm going to put in disk 1 first of all, and that is the standard MS-DOS boot. Hopefully it's going to work now. Volume's quite loud, let's just adjust that. And there we go, simple as that. So Amstrad PC640K version 1 motherboard. I've kept the replacement motherboard in there for now. It's asking to set the date and time. We have got valid CMOS batteries, but to set the time we just use the normal DOS time and date command. So time, let's give it a reasonable number. And same for date. I can't remember if DOS 3.2 is year 2000 compliant, so let's give it a date that's reasonably likely to be realistic. UK dates, don't forget, guys. So apologies to all you in North America. So those numbers should be remembered. So if we reboot, it has remembered them and we're not getting a warning message to type them in. So what's on this floppy? I've got normal command and config and stuff. Got standard DOS 3.2 F-disk. We've got a couple of extra things on here. So there's a RAM drive. So you can configure this machine to have some of the memory dedicated as a RAM drive. I don't think that's normal for DOS, but it's the way it was set up by Amstrad, it comes up that way. There's a folder here called images. What's in here? Aha, so I've got a couple of gem images in here. The screen looks a little bit yellow around the edge because I've set the auto white balance and I've also turned the room down so there's less reflections of me. So it just looks a little bit orange, ignore that. But anyway, yes, so we've got some gem images in there. I'll show you gem in a moment. But otherwise it's fairly standard DOS 3.2. Now I was expecting a program on here called NVR, which is not on there, but that's how you set the non-volatile RAM to set the equivalent of the BIOS in this machine. It must be on one of the other disks. But let's type gem, see what happens. Nothing. Okay. Okay, so suspecting there to be a RAM drive setup, which there isn't. Don't worry, because what we're going to try next is something that other PC XT users of the time were not getting to experience, and that is an alternative operating system. So Amstrad shipped DOS Plus with the Amstrad PC1512 and 1640, and DOS Plus was actually a DOS compatible implementation of CPM essentially, for XTs. This is version 1.2 from Digital Research, copyright 1986. And it has the ability to run some DOS programs, I think up to DOS 3.3-ish, something like that. But we're also going to get the experience of the GEM desktop. So it's asking us to take out that floppy and put in floppy number 3. I'm glad these are all working, by the way. That's more than I was expecting. So DOS Plus deserves its own video, so we're not going to cover that today. But it did come as standard with these Amstrads. So welcome to GEM. This is GEM on the floppy disk based version. As you can see here, C is called RAM disk, and the config for this set up an actual RAM disk, and it's the standard kind of GEM that you'd expect if you'd been using an Atari ST, but PC based instead. So we've got standard menus across the top, very much like a Mac, perhaps a little bit too much like a Mac, you might say. This is GEM Desktop 2, and because of the Mac likeness of it, version 2 was not allowed to have overlapping windows. There was a big court case. But this is from version 2 from 1986, back in the days when software was written by very small teams. But it does everything you'd expect from a Windows icon and mouse pointer point of view. We have graphical representation of folders and apps. Basic 2 was an interactive basic interpreter for the GEM environment. I think I've shown it in another video. Okay, so basically this is where you get your status messages, this is where you edit your program, and this is where the output goes. So you type in a little program here, or load it from disk. You've got load and save. Then we just run it. And our output appears over here. And as you can see, because it's graphics rather than text-based, it's quite slow. It's not super speedy. And don't forget this is being interpreted as well. But with this you could do a whole load of things that you can't do with obviously a normal text-based basic, such as changing colors, drawing patterns, doing fills. Excellent. So that was pretty impressive for the time. Let's quit that. So we have a working computer. We actually have some working floppies as well, interestingly. Okay, so here we have the Amstrad DMP3000. I've just taken it out of the box. Again, great to have it boxed. And it's a bit of a mess of wires and cables, but let me just break it down for you. There's only two things. There's a power cable, which is here, which is plenty long enough actually. That's decently long. And then there's a parallel printer cable, except have a look at this. So that's the Centronics end, and then that's supposed to be the parallel printer port end. Because it's not metal, it's blue plastic, and it looks extremely cheap. It's supposed to look like this, but this is how Amstrad saved money. It's an Amstrad branded cable, so super cost cutting there. Thank you, Alan. Looking at the machine itself, it's a fairly basic design. In fact, it's a very basic design. It's got this plastic cover which is removable. Tries to keep the noise down a little bit, because don't forget these were extremely noisy in their time. We've got a little switch here which is what lifts the platen for doing tractor or roller fed paper. This will take either. And then you've got some control buttons on the front. You've got your online on and off, and then a form feed and line feed, and a couple of status lights. This is the DMP3000. This was released specifically for the Amstrad PCs that came out, and there was a version before this called the DMP2000, which was specifically designed for the CPC range and was a black in colour or dark grey in colour. But otherwise, very similar printer. On the right hand side, you've got a paper advanced dial and the on-off switch. Around the back, you've got a parallel printer port, which is Centronic style, and a set of dip switches, which lets you change the fonts and the spacing. And I haven't got the manual that I found in the box. I haven't seen it manual in the box, but you can get the manual online. It tells you what you can change in here. I'd be interested to see what the existing user has put those as. This side is completely boring. Underneath, there's an interesting option, well, at least I think it's interesting. Considering this is supposed to be a budget printer, it actually has a tractor feed mechanism, and it has these little legs that fold out. So you can put a pile of paper on the desk and then stand your printer above it, and then the tractor feed draws the paper in through the back, through this cutout in the top cover. So it's actually pretty versatile for a budget printer. So you have it on your desk, and there's plenty of space here to have your fan fold paper come up the back. So definitely, you know, aimed at businesses, not just individuals. Another example of the cost cutting is the design of the ribbon, which I'll show you in just a second. This particular printer is quite dusty, and there's quite a lot of residue on the rubbers, so it does need a bit of a clean. Here's the print head. Tiny little thing, it's only a 9-pin, so quality's questionable, but you know, worked. And if you're doing multi-part forms, then that's exactly what you want. You want a 9-pin print head, and it moves along this rail here, and this is the ribbon. And it was a very budget design. You have these two little spools at either end and nothing in between. So there's nothing actually, unlike most cartridges, which are kind of solid plastic blocks. These two, which literally just pull off from memory. Yep. They just kind of loose, and when you take them apart, the cable goes very, very slack. Super budget device, but functional. So this ribbon is 40 years old now. There's no chance that's going to work. But should we put some paper through it just to find out? I think we should. So first of all, we need to connect it. We're going to use the parallel printer cable provided by Amstrad. So you can't really go wrong. Only one end fits on this end, and only one end fits on the other end. There we are, we're connected. It's plugged in, but I haven't powered it on. I've got some paper to give it a try. It looks like the lever needs to be in the rearmost position for this to work with paper fed from the front. We're going to turn it on and see what happens. Okay, it's beeping, and it's beeping because there's no paper. And we're going to get a paper indicator here. Power lights come on. The print head did move, surprisingly. I did kind of think it would be gammed up, but it did actually move, and it moved quite freely. Let's put a bit of paper in. So you put it in the lower half of these guides rather than the upper half. Paper light's gone out. In fact, let's leave the lid up, just you might be able to see the print head moving around then. So let's do a line feed. So the feed mechanism works as well. Let's do a page feed. Wow, that's working super smooth. All right, so most printers come with the diagnostics, whereby if you turn them on with one of these buttons or several of these buttons selected, it goes into a default mode where it starts printing out the character sets. Let's see if that works for this printer. Obviously not. Let's try a different key combination. Well, it is trying to print something. So I can hear paper being fed that way, I can hear the print head going that way. I can't hear any pins firing in the print head. It's too quiet. So I think there's probably a problem with the print head. Let's just see if the third button makes any different diagnostic. So now you can now hear we've got the print head going as well. turn that off and I'll just show you what it's trying to print out. So it's extremely faint, but it has attempted to print. So this machine is actually fully functional, apart from the fact that the ink has dried out. But if it's 40 years old, that is not a problem. Except it is a problem because you can no longer buy these ink ribbons. They were such an obscure one made specifically for Amstrad machines that no one else makes them for any other kind of commercial printer, so they're not available, unlike Epson or Citizen cartridges that still are. There is a company in Germany that I found that will recycle these. It'll recycle and re-ink these for you, 3 for 100 euros. So that is pretty expensive. I've got a feeling you can buy do-it-yourself ink for re-inking ribbons, so that we might have a go at doing that. But this appears to be essentially a fully functional printer, which is super cool. Let's put the lid back on. It is quieter when it's got that on. So this needs a clean, and we're going to try and re-ink that ribbon. But I'm amazed that without needing any lubrication whatsoever, that just works straight out of the box, which is great. I had one of these when I had my Amstrad 1512, and I used it for a couple of years. It did used to frustrate me because the ink in the ribbon used to run out really quickly, because most of the ribbon is exposed, because you've got a top bit and a bottom bit, only a little bit in the ink reservoir. It used to dry out all the time. If you didn't use it regularly, it used to dry out, and I very quickly upgraded to a 24-pin Star NLQ24 or something, I think it was, which was a much better printer, but didn't have anywhere near as much charm as this did. If anybody's got a box one of those want to send me, feel free. So there we have it. We have a working Amstrad PC1512. In this case, it's the DD double disc version with no hard drive, but it does have a colour monitor. At first we thought it had a faulty motherboard, but it turned out that wasn't the case. That unusually both floppy drives had become jammed and were therefore generating an error. That's not my experience of these machines. That's never happened to me before. So I was looking for an electrical fault when in fact it was a mechanical fault. But overall, I'm really happy with this machine. I am going to put the original motherboard back in to keep it all age appropriate and make sure those serial numbers nominally match, etc. It'll also be the correct revision for the board. It does mean we're going to go back to 1512K of RAM, but we do have those chips now. We can upgrade this machine or my original 1512 if we want to. And in fact, I think that's going to be the next video. We're going to upgrade this machine, put a modern hard drive in it, an XT IDE. We're going to upgrade the RAM. We're going to put an 8087 in there. We're going to load it up with some contemporary software and have a bit of a play. So I think that's going to be the next video, but I hope you enjoyed this one. As I've said before, it's one of my favourite machines from the last century. Definitely one of the most important machines in the UK for the 1980s, absolutely, and probably Europe as well. It was sold in America and a few other places where it didn't have quite the same impact, but in the UK it was an absolute standout machine. It democratized PC technology. Average people could afford to buy one of these for their own small business or for their own home, and it widely introduced many people to PCs. It has some quirks with those, Digital Research DOS Plus and GEM, things you wouldn't have normally found on an average XT of the time, and that's quite interesting. But fundamentally, a really nice XT machine. Hope you enjoyed watching the video. I certainly enjoyed making it. YouTube will be recommending that you do subscribe, and we'll be recommending a video that you might want to watch up here. We'll see you in the next one.